salmon is the next thing I wanted to talk about. And when I was reading about salmon consciousness, one of the reasons that people suggested that salmon don't have consciousness, and this, I don't know how you will react to this in relationship to the attention schema, but it's that so much of their behavior is driven apparently by pure instinct. Like they're just trying to get up this river, they're trying to mate. It doesn't seem like they are making complicated decisions. The narrative is, oh, they're on autopilot, they are not conscious.
Yeah, that's a silly argument. People are also very driven by, these kind of instinctive or reflexive behaviors. I mean, there's all kinds of weird drives built into animals, and so I don't think that means anything. And there's a lot of the world of animal consciousness is a bit obsessed with complexity of behavior, and so there's this whole
ants are complex.
Ants. Bees are a favorite because bees have really complex behavior, and people say, "Oh my God, they're conscious. They have complex behavior. That's it. Ta-da!" And then, the example of the salmon you just gave, well, they have behavior, and in some sense it's complex, but it's also very autopilot-y, instinctive, so maybe they're not conscious. Like, none of that means anything, because none of that has anything to do with this question of the experiential component. In the way that the philosophers, what I would call magical-minded people, think about it, I don't think they would agree with that either. And I don't agree with it either, even though I don't think that there's a magical component in there. I think what we say we have an experiential component because we have brains that process information in that domain about who we are and what our minds are. But none of those studies of bee complexity or salmon complexity, none of it addresses that. It's all about, is it so complex? Is the agent behaving in a complex enough way that my social machinery can attribute a human-like mind to it or not? And you see the salmon going up the river and you're like, nah, that's not similar enough to that I can attribute my human-like, I can't anthropomorphize that, so I'm not conscious. And that just seems silly to me, and it seems to miss the point. So I don't agree with that argument. On the other hand, if the theory that I work on is correct, then salmon probably don't have consciousness anyway.
Okay, so salmon have nociceptors, they have spinal cords, I don't know which of the other brain regions they have that would be relevant to this, but since they are organized more like humans than shrimp are, is it easier for you to explain with reference to the neuroscience, given that you're not an ichthyologist, why you're so confident that they don't suffer or have experience?
Well, I think they have the mechanisms of pain that we have. In other words,
nociceptors.
Yes. And they have,
so do shrimp.
Yeah, and they have some of the central connections that we have, some of them. But what does a salmon lack? It lacks a cortical system. It lacks the thing that processes the information that we say we're conscious of. Like, it's literally missing the parts of the brain that give us our consciousness. So whatever theory of consciousness you subscribe to, if you look at clinical patients and you see what they're missing and whether they're conscious or not, it's the cortex and the subcortical structures that connect directly to it, like the thalamus, and there's a couple other structures that are all involved in this big complicated loop. I mean, so the comparison is a bit easier with the fish because they have all these other components. They have the brainstem, and they have a cerebellum, and they have a tectum and other components in there that we have as well in one form or another. But I think you have to get pretty far up that branching evolutionary tree, pretty far up the complexity of the brain, of the forebrain, of the cortex, before you start getting these self models.
When we observe a salmon sorry for the dramatic language, fighting for its life at the end of a line, and it's bleeding and it comes out and it's flopping and appears to be suffering, given what you referred to as this social machinery in our brains. Are we making this conflation of complex behavior with experience that you were just alluding to earlier?
Yeah.
Okay.
On the other hand, I feel sorry for the things.
That I find, okay.
I feel sorry for trees when they get cut down.
Me too.
I don't want those trees cut down. This is awful. That tree's been there a long time. I just feel so sorry for that tree. And it has nothing to do with whether it has experience or brain or anything.
It's just because of how you're constructed.
Yeah. So I'm happy to feel sorry for the salmon. But scientifically, I do not think it has a self model. And so while it's reacting to pain signals, I don't think it has anything like experience in the sense that we do. That's what I would guess. I think the experiential, phenomenological experience is not there.
I think that this is an analogy that you might not like, but it's more like a computer in the sense that it's obviously, because we're just as mechanical as a computer is or as a salmon is, but the salmon is mechanical in the way that a car or a computer is, but in a way that we are not, just because we have this other mechanical component that is the self model.
That's right.
Okay.
Yes, and things are going to get a little squirrelier with these kinds of comparisons when the computers start getting that layer as well.
Okay.
And then it's going to get harder to use that vocabulary.
Okay. Salmon, interesting. And just for my future reference, if I wanted to Google this, or if our listeners wanted to Google this, you said that the cortex in humans is what is responsible for the sort of cognition that we associate with the self model, and it is the cortex that a salmon lacks?
Yeah.
Do they have a primitive cortical-like structure?
So they have something called a telencephalon, or the very front part of the brain, and it has. So it's tiny, but in evolutionary time it grows and it gets much, much, much bigger and eventually turns into this thing in reptiles called the wulst. And the wulst then...
And birds.
And famously in birds, right. So reptiles, I mean, this whole world of... reptiles is probably not the right word for it, but there's a split. And one lineage goes through the dinosaurs into the birds, and the other one goes through mammal-like reptiles into mammals, and here we are. And so this part of the bird brain and the human cortex are homologous. But you can trace it back, in a sense, to this little nub at the front of the fish brain. But it's really not serving the same kind of functions. And fish really don't have what I would call this cortical style attention, which is the heart of our consciousness, right? And so when you look at a human, at least, take a look at a human, you look at clinical cases and you ask, what are the people who have deficits in consciousness, who are really, what's the minimal damage such that the person is just not conscious? That's a little tricky because, of course, you can kill someone and then they're not conscious, and you can kill them with a very small lesion at the base of the brain, I guess. But if you look at what you can damage such that the rest of the brain is still functioning, what goes wrong such that the person is non-responsive, lying there unaware, unresponsive, unconscious. And there's certain areas that are in kind of two clumps, in the back of the brain and the front of the brain, roughly in the temporoparietal region, as it's called, and in the frontal lobes. These are the cortical areas that, when damaged, lead to this profound kind of deep coma. These are the cortical areas that process exactly what I'm talking about. The models of self and other, models of minds. These are the areas that answer the question when you ask people, are you conscious? Do you have subjective experience? Something in there has to answer those questions something in there knows what the questions mean because they process information in the right domain. Those are the areas. And so those get damaged, then you lose this whole consciousness thing. But fish don't have that.
I'm going to Tokyo in a few weeks.
Oh, right.
And so there will be a lot of fish being served. And if I'm not mistaken, earlier you said that you believe most fish don't have this, or did I mishear you and you believe that no fish have this self-model?
So to be clear, first of all, you're talking about a scientific theory. And I think the theory is right. But the details are not necessarily 100% known. And so I can only guess.
When you say that they're not 100% known, you're saying that, let's say, in the case of the salmon, it is conceivable that they have some other neural structure that produces a self-model other than the cortex, or you're saying that something else is missing or something else is not known just about how attention relates to what we think of as subjective experience.
I would say I am 99.5% sure that salmon don't have the structures necessary. Okay. But I could always be wrong in some way that's totally unanticipated. I'm much more sure, even though 99.5 already sounds really sure, I'm much more sure of the fundamentals of this theory.
Okay.
But exactly how different brains relate to the theory is, there's a lot that's not known. It's not like people have done vast amounts of neuroscience on fish. There is actually a fair amount, but it's not like people studied the details of the forebrain of the fish. So I put that out as a caveat. The answer is, in the context of this theory, as the details seem to fall into place, no fish, absolutely no fish has anything like that. The only animal that I know of that is outside that lineage that might have the same kinds of processes is octopus or cuttlefish.